Okay.
Okay.
Let's have a quick revision at the syllabus, which let me just recall what is deleted and what is not, chapter wise. I have also sent you something on your WhatsApp. That's the PDF which has been downloaded from the CBSE website. That is your revised syllabus. So if I just go chapter wise, please note it down in your copy, all of you. I'm just telling you what is actually deleted from each chapter. So this is 2022-23 syllabus. Now first your chapter 1, that is real numbers. So exercise 1.1 and 1.4, they both are deleted. Then from your chapter 2, which is polynomials. Now here your exercise 2.3 and 2.4 both deleted. Which is pair of linear equations. Now here you have your exercise 3.5 and 3.6. They both are deleted. Then chapter 4, which is quadratic equations. Exercise 4.3 is deleted. Now chapter number 5, which is arithmetic progression. Right? There is no reduction. This will come full. Okay, there's no reduction here. Chapter 6, that is triangles. Okay, now theorem number. So theorem 6.6, 6.7, 6.8, and 6.9, right? They are deleted, all four. And exercise 6.4 and 6.5, they both are deleted. Now next is your chapter 7, which is coordinate geometry. So here there's a topic which is actually deleted, not the, which is area of triangle. You know, sometimes you draw the lines and then a triangle is formed between them and we have to find its area. So that part is actually deleted. And plus then section formula, only external, right? There are two section formula. One is internal, one is external. So only the external is deleted. Okay. They both are deleted. And if I say exercise 7.3 is deleted. Yes, Hamna, is that okay?
Yes, ma'am.
Okay, this is a chapter number 7. So we have already done all these chapters. Just a quick, when you sit for revision, at least you can avoid few things we have done. You can avoid it in revision. Now, next is chapter number 8. That is trigonometry. Now here, exercise 8.3 is deleted. Then you have your chapter 9, which is applications of trigonometry. or it is also written as height and distance in R.D. Sharma. So there's no reduction in this chapter. Then chapter number 10, circles, right? Again, no reduction, full. Chapter 11, construction, right? Completely deleted. Now, next is your chapter 12, that is area related to circle. Here again, no reduction. The circle, there is no reduction, okay? You have to do everything. Then chapter 13, which is surface area and volume. So basically the topic, which is frustum, this is deleted, right? Frustum, this is actually deleted from the syllabus. So based upon this, you have exercise 13.4, which is deleted. Chapter 14, statistics, no reduction. Then chapter 15, probability. Again, there is no reduction. That's all. Yes, noted, both of you?
Yes, ma'am.
Okay. So let us finish chapter number 1, real numbers. I have finished the revision. Okay. The part which was remaining is actually deleted, which is exercise 1.4. So I'm not revising it. Let's come to 13.3 now of surface area and volume. Thirteen 13.3, right? So basically in this, it is based upon conversion of solid from one shape to another. So one shape to another means, for example, I have a cube, right? I melt it down and then I form it a cone. So that kind of problems are there in this exercise, right? First question, let us take first question. A metallic sphere of radius 4.2 centimeter is melted and recast into the shape of a cylinder. So there was a sphere, first of all, right? Whose radius was 4.2 centimeter. Now this has been melted and it has been recasted into a cylinder of radius 6 centimeter. So now you have a cylinder. right? Whose radius is actually 6 centimeter. Find the height of the cylinder. So you have to find h. Okay, now Harsha. Now since I'm melting like sphere and I'm converting this into cylinder. So which thing will remain same here? Like what
Ma'am, the volume.
exactly? So volume will remain same. So you write that volume of sphere is equal to volume of cylinder. You can write here, here volume of sphere is equal to volume of cylinder. So one by one, let us find out. Or we can directly put the formula here, I think. No, let's do it one by one. So write a heading sphere. Now radius is small r, which is 4.2 centimeter. So what is the formula for volume?
4/3 pi r cube.
Very good. This is 4/3 pi r cube, right? So put everything here. This is equal to 4/3 into pi, which is 22/7 r cube. That is 4.2 centimeter whole cube, right? Okay. So this is 4/3 into 22/7 into this. I can write 42/10, right? So 42/10 into 42/10 into 42/10, and then it becomes centimeter cube. Okay, now you can reduce it a little bit. So 7 into 1 and 7 into 6 is 42, right? Then 3 into 1 and 3 into 2, right? So let's not disturb the 10 of the denominator. Simply multiply it. And you can multiply at this stage, or you can leave it, because ultimately we have to equate it with something, right? So might be something get cancelled out. Getting it? So let's leave it like this. So finally I have 4 into 22 into 2, then into 42 into 42, and then divided by 1, 2, 3 zeros centimeter cube. Is that okay? So leave it like this. Now come to cylinder part. Now what is the radius of cylinder?
6 centimeter.
Okay, now one more thing here. I cannot denote it by small r, because if I'm denoting this by small r, I have to use something else. Either you call it r dash, right? Or you name it capital R, or anything, like give it a different name, not this r, because this is different. Okay. So let me call it capital R, no issue. So that is 6 centimeter. And height, I don't know. Like, what is the volume of the cylinder? The formula is,
Pi r square h.
so pi into capital R square into h, right? Okay. So you can put 22/7 into 6 centimeter whole square and into h. So that becomes 22/7 into 6 into 6 is 36 and into h centimeter square. Now we can equate it, okay? So volume of sphere is equal to volume of cylinder. Now, what is the volume of sphere? So put it here, 4 into 22 into 2 into 42. Carefully, please, into 42 into 42 divided by 1, 2, 3 and centimeter cube. It is cube, sorry. See, cube, why cube? Because height will also be in centimeter, right? So centimeter square into one more centimeter. So the answer will be in centimeter cube. Got it? Because this is volume, it has to be in centimeter cube. And is equal to volume of cylinder is this 22 by 7 into 36 into h centimeter cube. So now the units actually get cancelled out because you are going to get a number only. Am I right? No. One minute.
1 centimeter.
Yeah, let's keep 1 centimeter of h because ultimately in the end I need that. So keep it centimeter square here. And then 1 will remain, so that will come with h. Right. So here I have centimeter cube and then here I have centimeter square. Is that okay? So 1 centimeter will remain when I cancel out. Is that okay, Hamna?
Yes, ma'am.
Okay. So from here my h will be, oh, so much of calculations. See, first of all, 22 I can cancel out from both sides, right? Or you first of all do it, no problem. 4 into 22 into 2 into 42 into 42, right? And this 7 will come here and then everything in the denominator. So you have 1000 into then 22 into 36. And then, 1 centimeter will remain here and this is equal to h. Is that okay? Now in the last step, you can cut. So 22 cancels out.
7 will multiply everything, right? Like whole, right?
No, it's not plus in between. It's not a bracket. Everything is in multiplication, Harsha.
Okay.
When I have something like this, like a plus b divided by 3 is equal to, let's say, 1 upon 7. So in that case, I'll write like this, a plus b.
Okay.
Yeah, it's already in multiplication. Okay. So 22 gone. Now 6 into 6 and 6 into 7, right? And then 2 into 2, then 2 into 3, right? And then 3 into 1, 3 into 1, and then 3 into 4 is 12. So only 0 in the denominator now. So multiply the numerator. So 2 into 2, then I have 4, and 4 into 7 is 28, into 14, into 7 is left, divided by 1000 centimeter equal to h. So now can you multiply 28 into 14 into 7? Please multiply and tell me. I'm getting this 2744 divided by 1000 centimeter is equal to h.
Yes, ma'am. Got the same.
Yes. So just put decimals here. So after 3, that means 2.744 centimeter is your height. Please check the answer in NCERT at the back. Yeah, I think it's right. Okay, so the trick here is actually, please do not cut many things in the first step itself, right? Try maximum, or uh, I always do it in the last step like this. So that helps sometimes. Sorry, not here. I mean, like here, I have reduced so many things. So anyway, with practice, you will get used to it. Now, next question, number 2. Metallic spheres of radius 6, 8, and 10 centimeter respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. So basically 3 different sizes of sphere you have. And then something like this. You have melted all the 3 together, and the resulting, you have some sphere. And you have to find its radius. Got it? So let me call it R, right? And its radius, let me call it R1. This has radius R2. This has radius R3. So name everything differently because they are all different measurements. So exactly what will remain same here? I mean, the volume of the 3 spheres will be same as the volume of the new sphere, right?
Sure.
Yeah, so one by one, we will find out the volume. Then we will add it together, and then we will equate it to the resulting sphere. You can, like, this is your first sphere, this is your second sphere, and let's say this is your third. So let us find out volume of first sphere. The formula 4/3 pi r cube. So r means r1 cube this time. Okay, right. So now you can keep this 4/3 pi because it's going to appear in all the formula, right? So no need to put its value or cut it. Just put the value of radius. That's it. R1 is how much? 6 centimeters. So 6 centimeter whole cube. Leave it like this. Or you can multiply at least 6. So 4/3 pi. 6 into 6 is 36, and 36 into 6 is 6, carry 3, 216. So I'm getting 216 centimeter cube, right? Now similarly, a volume of second sphere 4/3 pi r2 cube. This is 4/3 pi. R2 is how much? 8. So 8 centimeter whole cube. That is 4/3 pi into 8 into 8 is 64, and 64 into 8, 512 centimeter whole cube, right? 6 into 8 is 48, and 3, yeah, 512. Now, a volume of third sphere is again 4/3 pi r3 cube. 4/3 into pi r3, 10 centimeter. That is simply 1000. So 4/3 pi into 1000 centimeter cube. Okay. Now we can write that according to the question, no, not according to the question, just write here, like here, volume of 3, no, not volume of 3. You can say combined volume of 3 old sphere is equal to volume of new sphere. Is that okay? The combined volume of 3 old sphere is equal to volume of new sphere. So we will add all the 3 volume and equate it here. So I'm doing it on the next page. Have you written all of you?
Yes, ma'am.
Okay. So first of all, 4 upon 3 pi. Now, what was the first? 216 centimeter cube, right?
Yes, ma'am.
Then 4 upon 3 pi, it was 512
512.
centimeter cube. Okay. Then I have 4 upon 3 pi into 1000 centimeter cube. This is equal to volume of the new sphere, which is 4 upon 3 pi r cube, which I'm denoting by r. So first of all, I can take 4 upon 3 pi common from here. I have 216 plus 512 and plus 1000. Then centimeter cube is equal to 4 upon 3 pi into r cube. So this cancels out. 4 upon 3 pi, 4 upon 3 pi, right? Both sides. Now you add it. 6 and 2 is 8. Then you have 2, 7. Please see. Is this calculation correct? See, this goes out both sides, right?
Yes, ma'am.
So on addition, I'm getting this. So cube root of this 1728 centimeter cube is equal to my r cube, right? So let us find by prime factorization method. So let's start with 2. 2 into 8 is 16, then 6 and 4. 2 into 4, 2 into 3, 2 into 2, 2 into 1 and 6, 2 into 1, 0, 8, 24, 2 into 20 and then 7, then 3 into 9, 3 into 3, 3 into 1. So you have cube root, so make pair of 3, combination of 3 like this, right? So that becomes 2 into 2 into 3. And centimeter cube, when it will come out, it will only become centimeter, right? Okay, 2 into 2, 4, 4 into 12. So 12 centimeter is, sorry, it is R only now. Oh, just a minute. This is now only R because I've already put cube root sign here, okay? So it's only R now, is equal to R. Yes, done?
Done, ma'am.
Okay. Next question now, number 4, 3. Okay. A 20-meter deep well with diameter is dug and the earth from digging is evenly spread out to form a platform this by this. Find the height of the platform. Okay, so well is actually in the shape of a cylinder, right?
Yes, ma'am.
So it's basically a cylinder you are having, and the earth which has been taken out, then it has been evenly spread, means in the shape of a cuboid. Understood? It's a platform like this, right? So basically it's a cuboid. Got it? So cylinder has been converted to cuboid and the volume will remain same. Fine, Amna? Because the earth which was carried out from here, that was equal to the volume of the cylinder. And that same volume has been just spread in the shape of a cuboid. Now what is given here? A 20-meter deep well. So the height is 20 meter of this well, that is cylinder, with diameter 7 meter. So this is 7 meter from here to here. Okay, platform 22 meter by 14 meter. Find the height. So this is 22 meter. and this side is 14 meter, and this height you have to find out. Let me denote it by capital H. So whatever you are writing, that only you will write in the formula, capital H or small h, whatever. Okay. So you can write one thing here, like here, shape of the well is in the shape of cylinder. Right? And shape of platform is in the shape of cuboid. So it is so what will happen, that volume of cylinder is equal to volume of cuboid in this case. So let us one by one find out and then we will equate it. Okay. Or can I write it like directly? What is the formula for volume of cylinder? Pi r square h, right?
Yes, ma'am.
Okay, do it separately to avoid mistakes. Cylinder. Now radius, which I'm denoting by small r, that is 7 divided by 2 centimeter, right? Height, which I'm denoting by small h, that is 20. Sorry, it's meter, right? Not centimeter. It's meter, and this is also meter. Now volume of cylinder is equal to pi r square h. So now see, cuboid doesn't have pi in the formula, so you have to put it here, right? When both the formula is having pi and then you equate it, so it actually get cancels out from both the side. But cuboid volume is length into breadth into height. There's no pi. So you better cut it. Sorry, put it. Into radius, that is 7 by 2 into 7 by 2. And height is 20, right? So 1717 will go out. And then 2 into 11. And this becomes 2 into 1 and then 10. So I have 77 into 10, that is 770 meter cube, right?
Yes, ma'am.
Okay. So now we can equate it. Putting in 1. Okay, so 770 meter cube is equal to volume of cuboid is length into breadth into height. Now don't write small h, okay? Because this height is different from the height of the cylinder. So 770 meter cube is equal to length is 22 meter, breadth is 14 meter into h. So 1 meter will remain, 2 meter will get cancelled out. So 770 divided by 22 into 14 meter is equal to h, right? Now again with the table of 11 you can reduce it. So 11 into 2, 11 into 7 and then 0. And again, so this is now 70 divided by 2 into 14 meter is equal to h, right? So basically 7 into 1 and 7 into 2, right? Then 2 into 1 and 2 into 5. So 5 by 2 meter is h, and that is 2.5 meter is equal to h. So height of cuboid is equal to 2.5 meter. Fine, Hamna? Okay, next question. Now, next is a good question, I think. Question number 4. Now, try to understand it. A well of diameter 3 meter is dug 14 meter deep. So again, basically you have a cylinder. It's a well, right? Okay. So now something is given that height is 14 meter is the height of this well and 3 meter is the diameter of this well. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter. Okay, to form an embankment. So what is happening now? The earth which has been taken out, now what they have done is like this is the well, right? This is your well. Okay. Now they have taken out the earth and they have made an embankment. So around the well, they have spread that earth. And obviously some with some height. Got it? This way uh, that has been spread out. Is that okay?
Yes, ma'am.
Okay. Mhm. I think it should go above it, right? Like this. Just 1 minute. If this is the well, right? This is your ground. Basically, this is the ground level, right? So you will put your an embankment will be having in height here. Is that okay?
Yes, ma'am.
Yeah, it will be like this. It will not go inside the ground. I mean, this is the ground level actually. So it will be having some height. And so this was actually the diameter of the, this much was the diameter of the well. And the thickness of the embankment is given from here to here. It is given that it is 4 meter, right? The thickness is given, which is 4 meter. Find the height of the embankment. So again, the embankment is basically in the form of a cylinder, isn't it? You can draw it separately. Like the embankment is looking like this. This is just for your understanding purpose, right? This drawing is just for your understanding. Now, what is given here? So it is given that the thickness of this embankment is 4 meter and you have to find the height from here to here. So if I call it like capital H, this you have to find, right? This we don't know. Fine, Amna? Okay. So both the figures are actually cylinders. Got it?
Yes, ma'am.
Okay. So, and you know that this much was actually the diameter of the your original well. So this is 3 meter. Understood? Okay. Let us give it some name. This is my cylinder first and this is my cylinder second. Just to differentiate because both are cylinders. Okay. Or old or new, you can call it. Old or new, you can call it. No issue. So one by one, let us find out. Old cylinder. Let's come to old cylinder. Before this, you can write the shape of the well. The well is in the shape of a cylinder. Right? And embankment is also in the shape of cylinder. Right. Now let's come to old cylinder. That is basically your well. What is the radius? Let us call it a small
0.
r. Yeah, 3 by 2 meters. Okay. And what is the height? Let me call it by small h, which is 14 meter. Now volume of old cylinder. Volume is pi r square h. Okay. So leave pi because you have to equate it. R is 3 by 2 meter whole square and into height is 14 meter. That becomes 9 divided by 4. Pi into 9 divided by 4 into 14 meter cube. Just leave it like this. Okay. Now let's come to new cylinder, which is actually your embankment. Embankment. Now radius, so don't denote it by small r, let me call it capital R. Okay, now tell me how much is the radius of my new embankment?
Small r plus 4.
Yes, very good. Yes, Hamna, is that correct? Now, basically, you have to do one thing, like don't write one radius here, write internal radius and external radius. Why? Ultimately, I need this volume, right? There's a gap in between, there's nothing here, right? So what I'll do is, I'll find the volume of the external cylinder, then I'll find the volume of the internal cylinder, I'll subtract it, so I will get the volume of this only. Is that clear, Hamna?
Yes, ma'am.
Yes. So let us write internal radius. Internal radius, I can call it R1, no problem. So internal radius will be same as this 3 by 2 meter. Yes, Harsha?
Yes, ma'am.
Okay. And external radius, let us call it R2. So this is now this from here to here and plus 4. Understood? So 3 by 2 meter and plus 4 meter. Is that okay? Yeah, is that okay, both of you?
Yes,
So
ma'am.
3 by 2 is 1.5 meter and plus 4 meter. So it is actually 5.5 meter is the external radius. Okay. So let me use the new page now. Now volume of embankment will be equal to, or you can say your new cylinder will be equal to volume of external cylinder with radius R2, right? Minus volume of internal cylinder with radius R1. Is that okay?
Yes, ma'am.
Yeah. So what is the formula? Pi r square h, right? What you have to find? Okay, height. See, height of both will remain h. Understood? Capital H. Internal as well as external, the height will remain same. So I can write pi into R1 square into capital H minus pi into R2 square into capital H. Is that okay? Now take pi common and H also you can take common. So pi into H and then R1 square plus R2 square. Okay. So pi into H. Now how much is my R1? Can I take it? Okay, leave it 3 by 2, no problem. 3 by 2 and 5.5. So 3 by 2 meter whole square plus 5.5 meter whole square. Is that okay? So this is pi into h. So that is 9 by 4 plus, so I can write it 55 by 10, right? 55 by 10 whole square, right? That becomes pi into h, and then 9 by 4. Now, can you
Ma'am, in
multiply?
the bracket it would be minus, right?
Oh, yeah, sorry. Yes, yes. Oh, I have just one more mistake here. This one will be R2 and this one will be R1. R2 is a greater radius, isn't it? This will be R2, this will be R1. Is that okay? External minus internal we are doing, right? So external radius is R2H, internal radius is R1. Clear?
Yes, ma'am.
Okay, so R2 square minus R1 square. Now R2 is 5.5, right? Whole square, and minus R1 is 3 by 2 whole square. I think this is right now. And then meter square you can take outside. Clear? Now this becomes 55 by 10 whole square and minus 3 by 2 whole square meter square. So can you just multiply 55 into 55? Getting this 3025. Please check the calculation. Yeah, is this correct? Now 104, I think the LCM will be 4 only. Oh, sorry, 100. Let us just check. 2 into 50 and 2. 5 into 5. So 2 into 2, 4. 4 into 5, 20. Yeah, so LCM is 100, right? So that is 3025 and minus 4 into 25 and then 25 into 9. So 25 into 9 is so I'm getting 225. Is this correct? Please check the calculation. So let us subtract it. No, something wrong I've done. 280. Yes, Hamna, is this calculation correct? And then divided by 100, of course. So 2 zeros will also get cancelled out. So I have pi into h into 28 meters square is the volume of my embankment, that is new cylinder. So I hope this is correct. Now let us come back here. So basically now the volume of the old cylinder is equal to the volume of the embankment. Is that okay? We will not write the there's one mistake here. Just listen here. Listen to me. All of both of you, please stop and listen to me. See, I'm calling it new cylinder, right? So I think this term is wrong because new cylinder means I'm taking whole volume. Got the point?
Yes, ma'am.
Yeah. So I should not call it new cylinder. I should call it embankment only. So please cut this new cylinder. Harsha, got it?
Yes, ma'am.
Okay. So now here volume of, just remove this, volume of embankment. That's it. That's right. So you can write like this. Now you can write that volume of well, or that you are calling old cylinder, is equal to volume of embankment. Embankment, right? This is right. Don't call it new cylinder. Now we have already found what was the volume. This was the volume. Pi into 9/4 into 14, right? So pi into 9/4 into 14 meter cube. And this is how much? Pi h into 28. So pi into capital H into 28 meters square. So now you can see pi cancels out, okay? So don't put the value pi here, it goes. Now H means 9 into 14, and so 1 meter will remain, and then 4 into 28 is equal to capital H, right? Okay. Now just to do some calculations here. So 2 into 2, 2 into 7. 7 into 1, 7 into 4 is 28. So it is 9 by 2 into 4 is 8. Meter is equal to H. Now divide this. So this is 8 into 1, then 10. 10 means 8 into 1, then 20, that means 8 into 2, 16, then 4, 40. I'm getting this is equal to H, right? Yeah, I think this is correct. You can check it. 8 into 1, right? So 120, right? 8 into 2 is 16, then you get 4, and 8 into 5. So it is terminating 1.125 meter.
Yes, ma'am.
Okay. See, these are having a lot of calculations, and you have to do it very carefully. Okay, then question number 5 I'll take up in the next class.